okay, so, we are getting to the last chapter. So chapter 20, you only have to focus on one section. So that's 23, dash 3. So just connect, okay, I wanna try to, open the space that, okay, so the cost accounting information can have more application, alright? So one of the application is in this, again, it's a short-term decision, alright? So when company face constraints, alright? So what do we mean by this? So this is basically, in the short run, the company will face a lot of constraints, and then the way we talk about constraint is actually bottleneck. Everybody understand bottleneck? What kind of example of bottleneck can you, do you have in life? Not just a company setting. Do we have bottleneck in our life? Do we see bottleneck? Yes.
Door is too small to get furniture through.
The door's too small, that's, okay, that's great. That's a bottleneck, and that's basically, okay, technological invisibility, right? Okay, what else?
Traffic could also be considered one.
Very good. This morning I got like going to traffic jam, okay, so that's definitely, right? So you have one way to get off a highway, right? So if that got clogged, right, so then they'll basically back up on all the whole highway. So that's okay, bottleneck, alright? So when you plan your study, do you feel like, okay, it's going on waves, right? So in some of the week, you kind of feel like, wow, so your time is not enough, right? Because you have all the exams, okay, happen in the same, okay, few days. So you kind of have, okay, your capacity is basically, right? So you do not have enough time to, okay, study for all the courses. So that would be bottleneck as well, okay? So the whole idea is bottleneck connect with capacity. So that's why, okay, if you look at the examples here, so it's all about, okay, so we talk about material, labor, and equipment, right? So technological capability. So those are all related to how much you can do within the company, right? So if, okay, there's a limit there. So that's basically what we call bottleneck. So one of the things I wanna convey today is basically, let's okay, try to set up a system, try to help the company use accounting data to identify bottleneck, alright? So if we can do that, that's a great help, right? So that's, so this is in a short time period, okay, so given we only have one class, so that's, I think that's something useful. And then besides, okay, we learn, okay, sort of like the theory of constraints. Alright, so let me, okay, so bottleneck create delays and increase production costs, right? So when the company has lots of bottleneck, then basically we said the company is not running efficiently, right? So the best way to improve profit and increase profit and improve efficiency is try to, okay, identify the bottleneck and solve it. Alright, so now, okay, before we do that, okay, I'm gonna set up the problem. So let's see, okay, so the manager, okay, so the manager manages two products, okay, A and B, with contribution margin. So now the focus is still contribution margin, okay, so especially we use contribution margin per unit. So that will be the selling price. So naturally it's already per unit minus the variable expense per unit, alright? So that is still our focus, right? So we spend the whole semester to talk about COGS. So that's basically variable COGS, that's part of the variable expense. Now, okay, so we have contribution margin 300 for A and 600 for B. Okay, so that's per unit. And then, okay, we asked the question, how many units of A and B should we produce and sell? So this is given, we do not have any constraints, okay? So, what do you think? With unlimited resource, okay, and unlimited demand, okay, how many units of A should we produce and sell? How many units of B should we produce and sell?
Just a bunch of
A bunch bunch of
Just as many B, so I guess in this situation, infinite B.
infinite B, alright? What about A? 0, why 0?
It's, half the contribution margin of B.
Yeah, but it's positive, right? So if I calculate, my operating income, that's profit, right? So I wanna maximize, so it's 300 A, 600 B, right? And minus fixed expense, right? But fixed expense it's a constant, right? So then, so I produce, infinite number of B. So then I increase my operating, asset. But even I produce 1 unit of A, I'm increasing my operating income by 300. Why not doing that? Right, so this is the key, so there's no constraint, right? So in the unrealistic world, if you do not have, any, constraint on demand, you can sell as many as you can produce, right? So then you're gonna do, also infinite number of A, okay? So simply because contribution margin per unit is positive, okay? So every time you produce a unit of A, you increase the profit by 300. Every time you produce a unit of B, you increase the profit by 600. And then of course, as long as those are positive number, you're gonna produce as many as you want. Alright, so that is so this is basically called unconstrained. Alright, so, and then we wanna maximize the profit, so this is a contribution margin, alright, and minus the fixed expense. And notice in the short run, fixed expense is not depending on A and B, so this is a constant, right? So fixed expense is a constant, alright, in the short run. In the long run, it's not necessarily true. So that's why we can reframe, so this is important. So we can reframe the problem as, instead of maximize the profit, we are gonna maximize the contribution margin, okay? So that will be 3A plus 6B. So that's the first thing we're gonna change. Okay, we drop the fixed expense. The only reason we drop the fixed expense because in the short run, it's a constant number, right? So it can be minus $10,000, right? So that it has nothing to do with the choice of the A and B. So that's why maximize contribution margin is the same as maximize the profit. Okay? So that's one simplification. Okay, so you have to, so this is related to the introduction class if you have learned like a relevant, right? Relevant cost. So when we make a decision, we look at what changes, right? So revenue changes, cost changes, we only look at what changes. Fixed expense do not change. So that's why, we drop it. Okay, so that's that's how you rewrite the problem. And then this is what we call objective function. Alright, so that's the terminology. Alright. And then the 300 and 600, that's important. Those are the coefficients. So that's contribution margin per unit. So just try to make sure, you get the terminology correct. Okay, you write down the objective function by maximize contribution margin. The coefficient for the decision variables will be the contribution margin per unit. Okay. All right, so now we introduce constraint because constraint is what we try to focus on, right? So we have external, internal. All right, so now let's look at this problem again. So we have 300, 600 as the contribution margin. Now, we have 60 units of A, so that's external. The market says you can only sell 60 units of A and 70 units of B. All right, so now, if I wanna write down the problem, so I wanna maximize, my objective is maximize the contribution margin, 300A and 600B, all right? So now we have some constraints. We're gonna subject to the constraints. One constraint is A is less than equal to 60, B is less than equal to 70. The idea is we do not want to produce more than we can sell, right? So we can only, so think of A as the units of A and B as the units of B, right? So we use, so this is basically how many units we want to produce for A and for B. Now, you do not want to produce more than you can sell, okay? So then that will be, 60 and then B is 70. Now, what will be the solution to this problem?
60 and 70.
Exactly, so because, okay, as what we, okay, discussed, without this, because the contribution margin for A and B are positive, you wanna produce as many as you want. So then, okay, so now given the constraint, you wanna produce to, okay, the biggest number you can, right? So that's why A will be 60 and B will be 70. Okay, so that's the argument there. Okay, so you wanna, just because the 300 and 600 are positive, so that's why you wanna produce as many as you can. So then you do not wanna produce more than, because that will be costly to the company. You have to think about the inventory management, right? So the warehousing fee and everything. Now, okay, given this, the contribution margin we can calculate now, right? So given we have an optimal plan, so 300 times 60 and 600 times 70. So that's a 60,000. So that's a 60,000, that's the optimal contribution margin. So that is not so bad, right? So this is a kind of very intuitive. So this is, okay, what you write, and then you get a solution. Now, okay, so I'm gonna introduce more, okay? Instead of, okay, looking at, okay, external, I'm looking at internal. So internal, the company has, okay, 3 machines. Okay, so this is the capacity. So the total 3 machine, if you run, okay, regularly, so then that will be 120 drilling hours. Okay, all right, so this is more important. So technological, okay, how A and B will use the, okay, the machine. All right, so let's say, okay, A, okay, defined as the units of A, and B defined as the units of B. All right, so then we can calculate the total drilling hour. So the total drilling hour, if I produce 1 unit of 1 unit of A, I require 1 hour of drilling. So given I produce, okay, 8 unit of A, so then the total drilling hour for A will be 1 time A. So same thing, so 3 times B will be the total drilling hour from B, right? So if I produce, okay, product B. So this is, okay, given A and B, okay, so A and B can be, okay, anything. So any plan we wanna have. So given you have it, so this is how you calculate the total drilling hour. So the total drilling hour, the constraint says you cannot exceed 120. Does that make sense, right? Because that's all you can do with the 3 machines. You cannot produce more than, okay, you cannot use more than 120. All right. So given this constraint, so this constraint is a little bit, okay, complicated. You can use less, that's no problem. That basically means we have idle capacity. But if you, okay, you cannot have more. All right, so, and then this is how we write down the problem. So maximize the contribution margin subject to the constraint. Now, okay, so then we can entertain, okay, some kind of, okay, different plans. Okay, so some plans will be feasible. So that basically means the total drilling hours is less than equal to 120. Some will be infeasible. So that basically means the drilling hours will be greater than 120. Does that make sense? Right? So it's all based on, okay, the capacity. Okay, so now let's look at, okay, suppose the plan is 120 units of A and nothing B. Is this feasible or not?
Yes, feasible.
It's feasible. Okay, the way to check this is you plug this back into the constraint. Okay, to calculate because this is the total drilling hour, right? So you, okay, calculate this, okay, what's the total drilling hour? And then compare with 120. If it's less than equal to, then that's feasible. All right, so if I do 1 times 120, that's exactly 120 equals 120, yes. So this is feasible, okay? Now suppose, okay, the plan is 40A and 20B. Is this feasible? All right, so is it feasible? One times 40 and then 3 times 20, right? So that's 100, less than 120, yes, this is feasible. Okay? Okay? All right, so what if 1040B?
No.
It's not feasible because 1 times 20 plus 3 times 40, so we get 140, which is greater than 120. So this is not feasible. Okay. Last one, A0 and B50.
Not feasible.
Not feasible. 3 times 50 is 150, greater than 120, so not feasible. By not feasible, basically we said we can't do this, right? So it's almost like you try to move the furniture through a small door. You can't do it, okay? Unless you dismantle, so destroy the door. Otherwise, you can't get the furniture into the room, right? So that's basically what this says. You only have 3 machines. You cannot do this, all right? So now, but identify the feasible. So feasible, you can do all this, right? But then our goal is to identify the optimal plan. So optimal production plan, the first and foremost, has to be feasible, okay? So optimal production plan is feasible. So which means when you try to search for the optimal production plan, you are not gonna look at this. You're gonna look among, all the plans which are feasible. So that's an important thing, okay? So which will be, very important to help us figure out how to solve the optimal. So now before, so I'm gonna, use, 2 different methods to solve this. One is using the economic intuition. All right, so now if you look at this, right, so the drilling hour is the resource, correct? So I wanna know between A and B, when I produce A and B use the resource, which one is more efficient? So in the sense that if I use 1 hour of A, how much contribution margin can I produce? That will be 300. And compare with if I use 1 hour on B, how much, so contribution margin can I produce? Wouldn't that be 200, right? So then that's how you determine. So basically you wanna convert the consumption or resource into contribution margin. So that's how how we think about the efficiency. So then to calculate contribution margin per drilling hour. All right, so all you have to do is for A, so then that will be 300 divided by 1, so that's a 300. And for B, that will be 600 divided by 3, that's 200. Okay? So this is so, and because 300 is greater than 200, so then we know A is more efficient. Are we okay? So A is more efficient in terms of using the drilling hours. Everybody agree? So this is A is more efficient, right? So now given A is more efficient, how are you gonna manage your plan if you were the manager? So I'm gonna use, remember there's no other, you can sell as many as you can produce, right? So I'm gonna use all my resources to produce A, okay? So then, because I wanna sell A, I'm not gonna sell B. So I'm gonna use all 120 hours, okay, to produce A. All right, so then it's 1 times A, because that's the total hours you need, equals 120, and that's how you get A star is 120 units. All right. Now, given, I'm already used up all the resource. I do not have a resource to produce B, so B will be 0. So that will be your optimum, okay? So then you can calculate your contribution margin. That will be 300 times 120. That's 36. All right, so that is, how you determine the optimum, okay? But this is, using intuition, right? So sometimes, so question like this is very clear. A is more efficient. There's no reason for me to spend any resource on B. So the reason you don't want to do that, imagine you also produce some of B, but doing that, you are losing $100 contribution margin, right? So instead of using the resource of A, right? So if you ever, okay, produce any unit of B, you are losing $100 contribution margin. So you do not wanna do that, okay? All right, so, so this is, okay, simple example, you can actually see the intuition. But I wanna introduce, okay, so, so you can read this. I wanna introduce, okay, another way to solve this, which is actually, a better method to deal with more complicated problem. So it's a graph method, all right? So the way to do that is, I'm gonna draw the graph. So this is between A and B, okay? For the constraint. Okay, so anybody know, okay, everybody know how to draw the graph of this? What shape is this? Is a curve or circle or is a something? Is a line or is a what?
I think this is straight curve.
It's a straight line, right? So if it's a straight line, you need a, because there's no quadratic, it's not like a square or anything, right? So you do not have something like this. So that's why it's a straight line. So if it's a line, all right, so you need only 2 points. You can randomly pick any point. So if A is 0, then I'm calculating, okay, A is 0. To make this equation hold, so B has to be 40, right? So that I'm getting this, okay? So that's 1 point, okay? Another point I can do is A is equal to 120, then I plug in, so B is 0, so I'm getting here, right? So it's 120, okay? So then all you have to do is this. So that will be your, okay, that will be your line. Now, how do you do this in Excel? Can you graph this in Excel?
Yeah.
How do you do it? Put the graph in, but you need to produce the graph. How do you?
Could you do an X and Y table with,
You do an X, Y table, very good, alright. So you do, okay, 2 column, right? So in this case, okay, is that, okay, so it's an X table and X and Y, right, A or B, right? So then you get a bunch of number, right? So then the question is, okay, how do you determine the column B? So then that will be, so it has to be B equals, 120 minus A divided by 3, correct? Because you wanna, okay, given A, you solve for B, correct? So then you have to, okay, calculate this column, right? So for instance, this will be 40. So then if I have 10 here, right? So then I plug in, so that will be 110 over 3, right? So you're gonna get a bunch of numbers, then you plot, okay? So that's how you, okay, do this line. So those are the basic skill. You need to not learning from this class, but you can learn from this class. It's not that hard, okay? All right, okay, my focus is not for you to, okay, learn how to draw the graph. It's more of how to use things, okay? So, so given this, okay, so this is a line. So with the graph, our first job is to identify the feasible set, because we know the optimal production plan is one of the feasible plan, right? So then how do we do this? Okay, I have the clean table here, A and B. So let me ask you, okay, if I have a plan right here, okay, so this plan is, I can read, A is equal to 80, B is equal to 30. Is this a feasible or not? It's not feasible, okay? So if you, okay, pick any point outside of this line, those plan will give you total drilling hours greater than 120. So that's why those are not feasible. Okay, so this is not feasible. Alright? Now if I put, okay, pick a point here. So this is a plan A equals 30, B equals 15. Is this feasible? Yes, right? So if you use, okay, A equals 30, B equals 15, and then calculate the total drilling hours, it will be less than 120. So everything here will be feasible, because that's basically the total drilling hours. 1A plus 3B is less than 120. And right on this line is 1A plus 3B equals 120, okay? But then, okay, outside of this, that's 1A plus 3B greater than 120, so that's why it's not feasible. Okay, you see the, okay, the three range here, okay? All right, so now given this, and then we can basically identify the, okay, the feasible set. So this is what you do. So starting from the, okay, the origin, and then trace the x-axis until you hit the constraint, and then you're gonna follow the constraint until you hit the vertical axis, and then you come down, all right? So that is the, okay, your feasible set. So everything within this, okay, triangle here are feasible, and we need to find the optimal solution here. Does that make sense? All right, now how do we do this? So very, okay, intuitive, all right? So if I have, okay, something, okay, some plan here, I can do better because I'm not fully use all my resource, correct? So there are two ways I can do better. Either I can, okay, so increase my sales production on B, or I can increase my production on A until I hit this line. This is the line I'm gonna, okay, so I'm gonna, okay, have exactly the same, so I can do two ways, right? So either way, I hit the, okay, so the total, I fully use my, okay, total capacity. So which means anything within this triangle are feasible but not optimal, because I can always do better by increase the production of one product until I fully utilize the capacity, okay? So now it come down to I reduce my search for optimal plan to this line, all right? So now for this line, so if I'm starting from here, so that's okay, I only produce B but not A. But then I'm moving down along this line, basically I'm switching using the resource to produce B by producing A, all right? So remember, A is more efficient, so every time I produce an actual A and not producing B, I'm increasing the contribution margin by 100. So that's why you ended up, it's gonna be right exactly here. So the whole idea is, if there's any differential efficiency between A and B, something in between will never work. So you can either, okay, use all the resources to produce B, as many B as you can, or produce as many A as you can. So it boils down to, you only have to compare the two corner solution, okay? So you, two corners, okay? So I'm gonna call this as X, call this as Y, okay? So all you have to do, okay, is that clear? Because everything in between is basically have some kind of combination between A and B. But we know A and B are not, okay, from an efficiency perspective, it's not completely the same. So that's why, okay, either you wanna use all the resources to produce as many A as possible or as many B as possible. So that will push you, okay, to the two corner, okay? So now we all have to do just, okay, compare corner. Okay, plan X, all right? So that's basically A is 0 and B is 40, okay? So all you have to compare is which one give you the highest contribution margin. So contribution margin will be 600 times 40, so that's 24, okay? And then I'm gonna, okay, compare, okay, plan Y. Okay, so plan Y is A equal 120 and B equals 0, okay? So then calculate the contribution margin, so that will be 300 times 120, so that's 36,000, okay? So 36,000 is is higher, so that's why, okay, plan Y is, okay, is the optimal, okay? So that is, okay, so how you, okay, so notice we arrive at exactly the same conclusion, okay, by using graph. So this is the way, okay, so there are two things you have to identify in graph. So first you have to, okay, draw all the lines for the constraints. Okay, in the short run, we only deal with lines, we are not dealing with, okay, curves or anything. And then, so which will help us to determine the feasible set. And then once you determine the feasible set, you only have to identify the corners because the optimal solution will be at the corner, okay? So that is okay, so that's why you only have to compare X and Y. Is that clear? Okay, question? Okay, so we are gonna use this, okay, so to solve for, okay, more complicated problem. Okay, so you can read this. So this is basically the trick. Okay, so we are looking at the corner solution. All right, so now let's look at, okay, so what if we combine both internal and external constraints? All right, so we have both the market and the firm. Okay, so we have the market now have, okay, 60 for A and 70 for B. Okay, so now what the way we do it is we're gonna, okay, so set up this, okay, contribution margin per unit. We have drilling our market demand, and then the problem we're gonna write is contribution margin, maximize the contribution margin, so 300A plus 600B, okay? And subject to, alright, so 1A plus 3B and less than equal to 120, alright? So that's the drilling hour. So then we also have A is less than 60 and B is less than 70. Alright. So given this, alright. Can you guess? Okay, what will be the solution?
60A and 20B.
Very good. Okay, so without this, we want to produce as many A as possible, correct? Without this, this is what, okay, the previous problem, okay, argued, right? So we want to produce as many A as possible. But with the market, we can only produce what we can sell. So that's why, okay, because A is more efficient, all right, so A is more efficient. All right, so I'm gonna, okay, produce, okay, A to the maximum we can. So that will be 60. Okay, so we wanna make sure, okay, this is 60. Now, okay, so given A is 60, and then we know we are gonna have some idle capacity. Because that, okay, so the total is 120 hours, but A is only used, okay, 60. So that will give us, okay, 60 hours of drilling. Okay, so that's the idle capacity. Then you're gonna use this, okay, use for B, all right? So then that basically means 3B equals 60. So then you get B will be 20. Okay, so that will be the argument, right? So first you're gonna, okay, produce the most efficient product. And then you're gonna calculate the idle capacity because it's costly for the company to have idle capacity. So you wanna make sure, okay, you do not have idle capacity. Then you, okay, so that's how you determine A and B. So then contribution margin will just be 300 times 60 and 600 times 20. Alright, so notice, okay, when you compare this, right, with the previous one, so the contribution margin decreases, right? So it's, without this, the contribution margin is 36. With the outside constraint, right? So remember this is, okay, 36, right? Without the market constraint, the contribution margin is 36. The more constraint the company face, the less profit or contribution margin the company is able to get. So that's basically why you want to, okay, identify those constraints so that you can increase the profit for the firm. All right, so then, okay, with the constraint, okay, our contribution margin dropped down to 30,000. All right, so now, okay, let's use the graph. Okay, so we always try to, okay, practice how to use the graph. Okay, A is 60, so this is the, okay, the drilling, right? So everything below this, that's a feasible, correct?
Yes.
Now, for the, okay, for the A, for the market, right? So the market is, okay, you can only sell for 60, so which means everything to the left is feasible, correct? So now, okay, for B, so that's 80, alright? So I think, okay, I think I already have it, I'm not gonna, yeah, alright. So everything to the left, and then for B, then everything below, alright? So now we have 3 constraints. Now the feasible plan has to satisfy all 3, okay? So you cannot say, well, I have a plan which only satisfies the drilling hour. Then, okay, that's not feasible. So for instance, if I have, okay, I have a plan to A is 90 and B is 5. So this is, okay, satisfy the drilling hour, but you can produce 90 units of A, but you are not able to sell 90 units of A, right? So if you can sell, you are now getting the 300 contribution margin. You have to be clear on that, right? So you have to match with the objective function. So which means now we have to, okay, identify the feasible set. Again, using the same trick. Start from the origin, go with the, okay, x-axis, alright, until you hit the first constraint, and you're gonna go up, alright, until you hit another one, and then you're gonna go, okay, until you hit the y-axis, and then this will be your feasible, okay, so this is, okay, so everything here, that will be your feasible set, okay? So now that's the first thing we do. Second thing is, well, so now we can identify the corner, right? So how many corners do we have here?
4.
4, okay? But then we are not gonna consider this, so that's why, okay, I'm gonna only circle the 3 corners, okay? So we're gonna have X and Y and Z, okay? So we have 3 plans. Now plan X, so all you have to do is compare the corners and then see which one give us the highest contribution margin. So plan X, so that's A equals 0, B equals 40, okay? So then contribution margin here, we already calculate that, so that's 24. Alright, so I'm moving down to, okay, Z, okay, plan Z, alright, so that's A equals 60 and B equals 0, okay? So this is, okay, 60, I'm producing 60 of A, but then since this is in the x-axis, that means B is 0, okay? So then the contribution margin is, so 300 times 60, that's 18, right? Now I'm gonna, okay, calculate Y, okay, for plan Y, alright? So plan Y, you actually have 2 lines, right? So 2 constraints, okay, intersect. One is A equals 60, okay? So A equals 60. The other is, okay, 1A plus 3B equals 120. So then you just have to solve A and B, right? So A already 60 and B, okay, plug into the second one, all right? So then you get 60 plus 3B equals 120. Okay, subtract, okay, 60 on both sides. Okay, divide with 3 on both sides. So then you get B equal 20. That's exactly what we, okay, what we calculate with the intuition, right? So then the contribution margin here, 300 times 60 plus 200 plus 600 times 20, okay? So that's 30. Okay. All right, so that is, okay, our optimal solution, okay? So Y is the optimal, all right? So that's the contribution margin. So this is B and this is A, okay? So we have A 60, B 20, and contribution margin is 30,000, which is the highest among the 3. All right. Now, with this, okay, since we have 3 constraints, so which constraint is binding here?
The constraints.
How many constraints are binding here? So we have 2 constraints binding, right? Because this is basically, okay, we have the drilling hour and we also have the market, correct? And then, okay, we have one loose constraint, which is the market demand for B. Alright, so now the binding constraints are the bottleneck. Okay, so whatever the constraint binding or the bottleneck, determine the result. If the constraint is not binding, you can always try to push and then utilize the resource. Only when you have the bottleneck resource, that's where it determines how far you can go. Okay, so that's why when you have the binding constraint, those will be the bottleneck. Now imagine if the manager say, well, so can you analyze where we can improve, right? So if you do not use this, you can say, well, so we can spend some resources to promote B because we only sell 20 units of B and 60 units of A, right? So, and B actually give us a 600 contribution margin. If you make that decision, it doesn't do anything, correct? So it's just basically you waste resource. So this is why, so you need to have, the bottleneck. You will say, well, so either you spend resources to promote the sales of A, so then you can push this constraint, to the right? Or you can also, let's purchase more machine to increase the drilling hour. Then this line will go up, right? So then either way, that will actually increase the feasible set and then improve the profit. So that is how you use the bottleneck. Does that make sense? All right. So this is basically where the concept of binding constraint, loose constraint, where you can actually so spend resource on in order to improve the efficiency. Okay. All right. So let's look at a more complicated problem. Okay. So this is again. So now we have three internal. We have cutting, welding, assembly. Okay. Now, which one is more efficient, A or B? It's not so clear anymore, right? You have to look at each one of them, right? So let me, so I'm putting everything, so this is basically the same, like 1 hour, 1 street and all that. Okay, I'm putting everything here, all right? So then you do the same trick, so in terms of cutting hours, I wanna see, every single cutting hour, how much contribution margin I can create between A and B, right? So that will be 300, 600, so B is more efficient, correct? So this is B is more efficient. When I look at the welding hours, right, so that's 300, and then 1 hour per 300, and then this is 1 hour, and then 200. So then A is more efficient. All right, so then if I look at assembly, right, so this is 150 per assembly hour, so this is 600, so then B is more efficient. So when you get to more complicated and also more realistic setting, so it's really difficult to think about, so to see, definitely, producing A is more efficient than B, right? So this is, usually you will get into this kind of scenario, right? So it's really difficult to see how you're gonna spend your resource. So this is why instead of try to use economic intuition, and then we use some other tools, such as, we use the graph, okay? All right, so let's write down, so the problem, so maximize, so this is why, knowing how to solve using graph is very important here and then useful. So you have 300A and plus 600B, okay? And then subject to, all right, so, and then you have 1A plus 1B, okay, so less than equal to 80, okay, so the 80, so that's given, right? So you know how many machines you have and how many hours you have. And then 1A and plus 3B, okay, so that's less than equal to 120. And then you have 2A plus 1B is less than equal to 90, okay? And then you also have A less than equal to 60 and B less than equal to 80. All right. How many lines will we have in the graph? 5, right? So we have 5 constraints. You need to put those constraints in the graph in order to identify feasible sets. So this is why, okay, so we're gonna, I'm already, okay, so draw the line, finish drawing the line for you. Alright, so the first one, this is cutting, okay, but you have to understand everything below this line that's feasible, okay? And then the second is welding, so this is the welding line, everything below, okay? And then you also have the assembly, so everything below this, okay? So now you have 3 lines, and then we also have A is 60, alright? So this is A equals 60, and we also have B is 80, alright? So everything okay on this and everything down below. Alright, so given this, and let's try to, okay, figure out the optimal, the feasible set. So I'm starting from the origin, so then move until I hit the assembly, okay? And then I go up until I hit the, okay, constraint for welding. And then I'm gonna go up until I hit the, okay, the vertical axis, so then I get my feasible production set. Okay, so that will be this, right? So how many corners do we have to compare?
3.
So we will have 3 corners, all right? So X and Y and Z, okay? All right? So X, we already know that. Okay, so that's A0, B40. Okay. So you have to be careful. The only reason I say I already know that because we already calculated this, but this is essentially A equals 0, and then because of this line, you have to be careful, that's welding, so then that will be A plus 3B equal 120, correct? So that's how you get, okay, so plug A0 into the second one, you get B equal 40, okay? So then contribution margin will just be 600 times 40, so that's 24. All right, for Z, all right, so Z, we have 2 equation as well, right? So we have one is B equals 0 because it hit the, okay, the x-axis. And then also, we have the assembly line, right? So that's the 2A plus B equals 90. Alright? So then this basically means, okay, if you plug in B equals 0, so then you get 2A 90, so then you get 8 is 45, alright? So which means contribution margin here is 300 times 45, so that's 13,500. Okay. All right. What about plan Y? How do we determine plan Y? What 2 constraints do we have to write down?
The assembly and the
Very good. Assembly and welding. All right. Everybody feel comfortable to solve this? Why don't you try to solve it? I can do a substitution, right? 30 and 30 sounds right. Okay, so the first one we get, okay, 90 minus 2A, right? So then you plug into the second equation, right? A plus 3 times 90 minus 2A, that's 120, all right? So if you solve this, that should be A equals to 30, okay? All right, so do it a little bit slower, okay? So that's 270 minus 6A equal 120, okay? So subtract 120 on both sides, you get 150 minus 5A equals 0. So that's how you get A equals 30. Okay, so if A equals 30, you plug into B, so then B equals 30 as well, okay? So then the contribution margin will just be 300 times 30, 600 times 30. Okay, so that is 27. Alright, so 27, so that's the highest. So then this is Y, okay, so our optimal is Y. Okay, so this is A is 30 and B is 30. Okay, alright. Where is our bottleneck?
The bottleneck would be in assembly and welding.
That will be assembling hours and the welding hour, right? So then that's your bottleneck, correct? So which means if you wanna improve the efficiency, and then you need to, okay, so work on those two departments. But cutting department, you do not need to worry about, because at this moment, it's not, okay, it's not a bottleneck. But imagine, suppose the company actually increase the assembly, right? So then this will, okay, move to the left, and then this will move up, right? So it's possible at some point that the cutting hours will become bottleneck, right? So that's why this is a continuous, okay, so work, right? So you need to, okay, whenever there are some changes, right? So the capacity changes. And then also demand, market demand changes, right? So you need to go back to this problem and try to solve again, where's the bottleneck and where you can improve and so on. But the basic idea is, well, so this will be a very systematic tool to help us identify the bottleneck. Okay, so and use the accounting, the cost data to help to provide decision, to provide useful decision. All right, I think so that's all the material I want to cover. So you can read the takeaway yourself, and this is the concept for 23. All right, I want to spend a little bit time to conclude. Okay, so anybody heard about Dilbert? The comic? No? So maybe because you guys are a little bit too young on this. So Dilbert comic is basically largely on company. Okay, so it's mismanagement, some silly policy implementing in the corporate, and then the author actually use the comic to address this. Okay, but that's not the point. I want to talk about that. Okay, the point is so the author of Dilbert is called his name is Scott Adams. So I want to kind of introduce this book. It's Reframe Your Brain, which is a fun read, since I have been doing some of this. I want to kind of talk about the idea. Some of the idea. One of the things is thinking about managing your goal versus the system. Okay, so usually people will think, I have a goal I have to achieve, right? So versus, do I have a good system to achieve the goal, right? So this is at the beginning of the year, at the semester, I said, well, so try to find a way, what works for you, right? So for this, with this class, right? So what things you have to do you have to, on what day you have to finish your homework and everything. So that's a system, right? So if you try to pay attention to the system rather than the goal, is actually more productive, because the same kind of system, if you work on one thing, it probably will work on several things. So that's one thing. Another thing is, usually people will talk about managing time. So there's another way of saying managing energy, right? So rather than think about, do I have time today? You will talk about, what will be the time, of the day where I have the most energy? And then that's the time you're gonna, arrange your study, your work, at that time, and to be the most productive, right? So that kind of reframe is also very important. You just consciously, right? So sometimes, it seems to be intuitive, but if you don't think in that way, don't intentionally do that, that probably will not be as useful. The third one is basically, instead of saying, I want to be good, to be the best, on certain scale, I want to build a talent stack, Okay, so he talked about, okay, what does that mean to have a talent stack and so on. So I wanna, okay, bring that concept into like accounting, right? So if you wanna, okay, be a public accountant in the future, so you work on audit, but it doesn't mean you shouldn't learn about tax. You shouldn't learn about, okay, management accounting. If you wanna do tax, doesn't mean you shouldn't learn, okay, financial accounting and managerial accounting. So things like, okay, if you can be the best of knowing or have the most knowledge about cost accounting while you are doing the tax work, that will help, right? So that's the, okay, the talent stack, which is actually more useful than nowadays than ever. So from book to read. All right, so the next slide is sort of a trick. Okay, so since you guys, okay, have been the constant, okay, so showing up in class, so I wanna, okay, share this with you. So I'm gonna, okay, put all the, okay, definitions and terms, okay, in one slide. I'm gonna run through the slides. You're gonna see the terms, okay, so see whether, okay, how many, okay, can jog your memory and then, okay, ring the bell and then can you get 100%, okay? You should know all of them, right? So there should be some music built in, right? What's contribution margin?
I don't know.
Very funny. Look familiar, right? All of this look familiar, right? This is how much you know for the whole semester, right? I'm gonna fill out the whole page. You know that. Go Harlow. Remember that? Alright, that's it. That's how much you know. Okay? How 80%, 90%? 100%? Should be 100%, right? So it should be 100%, you know this, alright? So that's the, okay, that's how much we have gone through for the semester. But then of course, this is a much more boring, summary of what we have done, so you can read on your own. I'm not gonna share the other slides, okay, with the class, but I'm gonna post this, on the website. All right, so my goal is, so you get some trainings to start, okay, feel like you can think like a accountant, right? So using T-chart and, okay, I like you to, okay, don't think about, okay, this is just one class, okay? You should, okay, apply this to all the accounting classes. So that's important. Diversify your skill, right? So that's basically, okay, like a link to the diversify your portfolio. You know that in investment.
Yeah.
So diversify your skill, that's important. That's the talent stack idea. Then next class we are gonna do, okay, I'm gonna post the review notes. And then, okay, next class we're gonna, okay, review. I'm gonna, okay, so tell you, okay, what